Number 19. The function f of x equals 1/9 times x minus 7 squared plus 3 gives a metal ball's height above the ground, f of x in inches, x seconds after it started moving on a track where 0 is less than or equal to x is less than or equal to 10. Which of the following is the best interpretation of the vertex of the graph of y equals f of x in the xy plane? Okay, before I look at their options, I'm going to look at this parabola. Now you absolutely can graph this by just putting it in your graphing calculator, putting it in Desmos. Totally fine. Honestly, I think it's a little faster if you're very familiar with how these numbers change our basic parabola. You can sketch this pretty quickly. I think it's faster than going to Desmos. Every second counts on the SAT. So I'm going to show you, what you're going to get either way. Okay, so here is, the sort of principle about translating functions on the xy plane. If I just have an x squared, it's going to be a parabola that opens up and the vertex is at 0, 0. That's just, x squared. Now there's all these different numbers, all different things we can do. I can put a negative in front of the x squared. I can put a number in front of the x squared. I can, add something to the x squared or subtract something. Or I can put in, the number inside here. Each of those moves this in a very specific and predictable way. So one by one, if you have a negative out front, a negative x squared, it flips it upside down. If you have a number in front of it that is greater than 1, it's going to squish it and make it narrower. If you have a number in front that is positive but less than 1, a fraction that's less than 1, it's going to make it wider. If you have a number outside of the x squared, it's going to move it on the y-axis exactly as you see it. So here plus 3, it's going to move it up 3 points. Nothing else will change, it's just going to go up 3. If you have a number that is inside the x squared, it moves it left or right, but it moves it the opposite way. So x plus 3 would move it 1, 2, 3 to the left towards the negative x. And you can combine all of these together, which is what's happening right here. Again, if you have these rules down pat, you can look at this right here and go, okay, so I'm starting with an x squared, just a plain x squared, and it's positive, so it's still opening up. All right, that 3 is going to move the vertex up 3 points. And then that minus 7 is going to move it the opposite, so plus 7 on the x. 1, 2, 3, 4, 5, 6, 7. Okay, so it's going to be there, and 1/9 means it's wide. Okay, so I've got a wide parabola with a vertex at 7, 3. Okay. Now see, I did that little quick sketch just by looking at that. Personally, I think I could do that faster than going over to Desmos and typing in f of x equals 1 divided by 9, parentheses, x minus 7, parentheses squared, plus 3. It's up to you. They're close. They're close. But for me, I don't like flipping back and forth as much. I like staying where I'm at. And if I can do it pretty quickly this way, that's what I'm going to do, because that's what works for me. And we're also told it's where x is between 0 and 10. So it's starting here, and it's going to 10. It's about like there. Okay. And it's, it's going to cross. I don't know where it's going to cross, but, it's starting there. And this is what's happening to this metal ball. Right, so which of the following is the best interpretation of the vertex of the graph, this 7, 3? And we are told, actually, just to make sure, the ball's height in inches, so this is inches over here. My y is inches, and x seconds. So my x over here is seconds. So that applies also to the coordinates. This is 7 seconds, 3 inches. So let's look at our options. What does this at 7 seconds, it's at 3 inches mean? Which of the following is the best interpretation of the vertex? Option A, the metal ball's minimum height was 3 inches above the ground. Yeah, that looks right, because it was going down and then it came up. This is a minimum point. And it was at 3, and we said that the y is inches. It's like, hey, A looks like our contender. B, the metal ball's minimum height was 7 inches above the ground. No, the 7 is how many seconds after it started rolling. It's our seconds, so no, B is on. not our option. C, the metal ball's height was 3 inches above the ground when it started moving. Nope, that would have been over here somewhere at 0, and then it went down 7 seconds later. So it was not at 3 inches when it started rolling. It was higher than that. And D, the metal ball's height was 7 inches above the ground when it started moving. Same sort of thing as 7 inches. You know, I don't know. If I did the value of 0, I could find out how many inches it was above the ground at 0 seconds. I don't think it was, at 7 inches, but I would have to do that math to be sure. But it doesn't matter because it's not asking about what happened when it started moving. It's asking about the vertex, which is 7 seconds later. So both of these that are talking about things when it started moving. No. A is absolutely our answer. It was 3 inches above the ground at its minimum. Hey guys, just a quick heads up. I've got some cool stuff coming for y'all, including a free course full of SAT tips and tricks, as well as an exhaustively complete course on everything you need to know for the SAT, both math and reading. So subscribe to the channel to get notified when that goes live. I'm also going to put it in the comments and description below as soon as it does. In the meantime, if this video was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.